Hi, welcome to the section 1.3 notes on segments and measurements. So the first thing it's asking here is to find the distance between 2 points on a number line by what? The spaces. So one thing you can do if you think about it is just count the spaces. Quick and easy way. So counting. And on example 1, it says, what is the distance between D and F on the number line? So if we use that method and, just count 1, 2, 3, 4, 5, we can see that the length of DF, or the distance between D and F, is 5. Okay, make sure if you're doing that you are actually counting the spaces, not the lines, or you're going to get an extra one. But besides that, you should be good to go. It says if segments are written without the segment symbol, AB, so no line on top, it means the measure of segment AB or the length. I'm going to write measure. But you can think of it as the length also. So you do just want to get used to that with geometry, all these little technicalities about the symbols. No line on top means the measure of or the length of. Line on top means you're actually talking about the line segment itself, not the number value associated with it. On example 2, it says, what is the measure of AB? So if we use the method we just talked about, and we want to count the spaces from A to B, it's a little further apart this time, a little more of a pain to count, but we can do it. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so we can say, okay, the length is 13. And that would be our method I'm going to write here of counting the spaces. Okay, but the further apart the points get, the more impractical that gets to actually count. So if you try and think of other ways to do that, and it's a good idea to think through some of that yourself. Think, is there another way I could figure out how long it is from A to B? One person might look at it and say, okay, well, I can quickly just look at this and see that from 0 to -9 is a length of 9 without actually counting it. And I can look at this and quickly see that from 0 to 4 is a length of 4. And they may think of it as, I'm just going to add 9 plus 4 to get the 13, and that would work out fine. Okay, someone else might think of it as subtracting. They might think of the fact that I could think of it as, bigger number minus smaller number to see how far it is in between. So they might think of it as 4 minus -9. And if you think of it that way, then you would get 13 also. So any of those methods would work in this case. What is the measure of BC? Again, I can quickly count the spaces. 1, 2, 3. And I can say it has a length of 3. Example 3 is a little different, though. If we look at that, it says on a number line, V is at 1039 and point Q is at -125. Find the distance. So I think you can see that it would not be super practical to count the spaces in this case. So one of these other methods is maybe going to make a little more sense. I still think it's helpful to put it on a number line to kind of have it as to visualize it. I always like to make sure I have 0 on the number line as a reference point. I know that -125 is going to be somewhere to the left of the 0, but it doesn't have to be specifically one particular location. And I'm going to name that Q. And I know that V is at 1039. It's somewhere to the right. And that is our V. Okay. And if I want to find the distance, if I think of it like we talked about a moment ago, I can say that I'm going to go from here. So I can say from here to here is 125. And I can say from here to here is 1039. And so I could quickly just add those like I did up above in one of the methods, 125 plus 1039. And when I add those, I end up with 1164. Okay. The next part talks about the segment addition postulate. Segment addition postulate, or you can abbreviate it as SAP or SAP. We are going to use a lot of geometry. It's going to show up in other chapters. So this is a concept you really want to kind of get stuck in your brain. It says if 3 points A, B, and C are collinear and B is between A and C, then what? So I often in geometry recommend that draw a picture if a picture is not provided so that you can visualize what's going on, and then you can kind of make sense of what it's wanting you to do. So if I go ahead and draw, yeah, I can draw, actually, I'm just going to draw a line segment. So if I go ahead and draw a line segment, and it says that A, B, and C are collinear, meaning they are on the same line. I could draw this as line or line segment. I'm just running out of room, so I'm going to go as a segment. But they're on the same line, and B is between A and C. So I've got my A here, I've got my C here, and B is somewhere in between. Notice I didn't put it right in the middle because between does not mean right in the middle. We'll talk in a minute about what it would be, what it would say if it did want it to be right in the middle. So now I need to fill this in. It's saying something plus something equals something. You know, you can try to fill that in yourself based on this picture. And then once you have done that, hopefully you can see that this little piece plus this little piece has to be equal to this big piece. Okay, so I know that AB, one little piece, plus BC, the other little piece, has to be equal to the whole big piece, which is AC. Okay, so we're going to use that a lot. Let's go ahead and move. Oh no. Move this up a little bit. Oopsie. Okay. Sorry, I'm taking a while to do this. Okay. It's moving on me. All right, that's where I want it. I'm gonna erase this little guy right here. Okay, so now if you look at this one, we can use the segment addition postulate to actually solve a problem. So I know in section 2.1, I don't know if you saw any numbers in that whole section. It was lots of words, lots of ways to write things in geometry. And now you're finally starting to see some numbers in this section, which I know some of you like. And we're actually getting to do some algebra and solve some equations. So if we see what they're giving us in the problem, it says EG with no line on top, which means the measure of EG is equal to 59. And I can mark that on my picture. I like to use these brackets that from here to here has to be 59. It tells me that EF, the measure of EF is 8x minus 14, and I can put that on my picture. And it tells me FG is 4x plus 1. Okay. And if you think about it, very similar to what we just did a minute ago with the segment addition postulate, we can write an equation, a true equation based on this information. Some people like to do it with letters first, and then they'll start plugging in the algebra. Some people do not like to do this step, but I'll just show you, if we want to do segment addition postulate, we can say this little piece, EF, plus the other little piece, FG, must be equal to the whole big piece, which is EG. Okay. From there, you can go ahead and start plugging in some of the algebra. So EF, I can see as 8x minus 14. Okay. FG is 4x plus 1. So I'm going to say plus 4x plus 1 is equal to, my writing's not working very well here, is equal to the whole piece, which is 59. Okay, now you're just solving the algebra from there, and then we can move on to part B. So in terms of the algebra, remember, we're going to combine our like terms together. The 8x and the 4x combines together to give me 12x. The negative 14 and the positive 1 combine together to give me negative 13, and that's equal to 59. From there, I can go and add 13 to both sides. So I get 12x is equal to 72. And I can divide by 12 on both sides and get x is equal to 6. Okay, so just a little refresher on solving equations. Now I need to look at part B. I'm not necessarily done just because I solved for what x is. On B, it says to find what EF is and find out what FG is. So if I know that EF is 8x minus 14, and I take that 6 and plug it in for x's place, then I can solve from there. 48 minus 14, and that gives me 34. And I always like to make sure I'm specifying in my answer, well, what is 34? I don't want to just circle a random 34. I'll make sure what that actually goes with. For FG, I have the expression of 4x plus 1. I now know what x is, which we just said is 6. And if I go and add that up, I get 25. And again, I can be more specific and I can say that FG is 25. I think it's helpful to bracket your answer just so you're saying what your actual answer is to that particular question. Now I want you to think about, how could I check to see if those answers are correct? I just did all that work. I may have made a careless mistake. I want you to think, how could I check to see that that is actually the right answer? And it's a quick little check. And in this case, if I want to check it, if I know this whole length is 59, and I just got the two pieces, if it helps you to put them in the picture up here, I got that this is 24 and this is 25. If I add those up, it should give me 59. That would make sense if it does. I can do a quick check to see that it does check out right. And so I know that I've done all that work right. So I think it's a good use of your time to do that. Okay, on example 5, they did not give us a picture this time. It's still a very similar problem, but they didn't give us a picture. The other thing, if you notice, is a little different, is that they didn't ask you to find x. But I want you to think right now, if they're telling me j, k, and l are collinear, and they're telling me k is between j and l, and then they're giving me these expressions, do I have to find x before I can find j, k, and kl? Okay. The answer is yes. It's still similar to the last one where you still have to set up a true equation based on the information. You still have to solve for x, and then you can plug back in for what it's actually asking for. So just don't get confused. Even if they don't tell you to find x, sometimes they're just assuming that you know that you need to do that before you find JK and KL. So on this one, let's go ahead and set this one up together. And then I will pause my video and let you have the chance to actually work it out, plug back in for JK and KL, and then you'll come back on and see if you did that right. So if we go and draw a picture to represent this, switch to a different color this time. I'll do some red. So JK and L are collinear. So let's see, I'll do it right here. So I'm doing a line this time. So it tells me K is between J and L. So here's my J, here's my L, and K is somewhere in between. Okay, I can go ahead and label my picture. It tells me JL is 120. It tells me that JK is 4x plus 6. And it tells me KL is 7x plus 15. Okay, and so now I want you again to pause the video. I want you to set up a true equation. I want you to solve for x, and then I want you to plug back in to find JK and KL, and then come back on and check your answer and see how you did. No big deal if you don't get it right. You can always take the time to correct it once you come back on. So let me pause this for a moment. Okay, so now you can see the work and the answers that I did when you were off. So go ahead and check those. See if you set up your true equation. See that you solved for x and got x is equal to 9. That you plugged back in and got JK is 42 and KL is 78. And then remember what we said a minute ago. We can do a very quick check to see if it's right. And if we go and add up 42 plus 78, we get 120, which is what we were supposed to get. So that checks out. So we know that we did all that work correctly. All right, let's move on to the next one. Having a hard time moving these. Okay, so on this next part, this problem is very similar to what we just did. So on this one, I want you to go ahead and label the picture and set up your true equation, but then I want you to stop there for a moment and then check with mine to see if it's right before you take the time to solve it. So I want you to label your picture, I want you to set up your true equation, and then, or I guess pause the video while you do that, and then you will unpause the video and see if you have the same thing I do at that point. Okay, so check your picture, how you have it labeled, and check your equation and see if you have the same thing I do. If you don't, if you have the equals 21 on one side of your equation and all the other stuff on the other side, look back at your picture. See how on your picture you can see the two little pieces are 2y and the 21, and the big piece is 3y plus 1. So you have to make sure you have it set up appropriately. Sometimes just because the last two problems had the variables on one side and the number like the 21 on the other side, they just assume it's going to be that way this time. Because you just have to make sure you're setting up a true equation every time. And in this case, it's going to be 2y plus 21 equals 3y plus 1. So if you don't have that, go ahead and fix that now. Then I want you to pause the video again, take the time to solve for y, plug back in to solve for PQ. That's the only thing it's asking for this time. And then jump back on and check yours with y. Okay, so if you go and check your work from here, you should have gotten y is equal to 20. Should have taken that 20 and plugged it in for the PQ expression and gotten PQ as 40. So that's all the problem is asking you to do. You can be done at that point. But if you want to check your answer, you can certainly do that very quickly, just like we did before. If I take that 40 and plug it back in for QP, then I would have 40 times 2, which would be 80 up here. Down here, I would have 40 times 3 is 120, plus 1 is 121. And again, I could do that quick check to make sure that I've got 80 plus 21. That gives me 121. And yes, that checks out. Right now, it's mentioning congruent segments. You may not be familiar with the word congruent. It's an equal sign with a little squiggly on top. But what it means, it's segments that have the same length. Okay, if numerical expressions have the same value, they are equal to each other. Okay, so if we're talking about numbers, then we're going to use an equal sign, just like you're used to from past math classes. But it says similarly, if two segments have the same length, the segments are congruent. And this congruent symbol is going to be used a lot in geometry, but we're also going to use the equal sign a lot. And it's really important to understand when to use each one. It's kind of a little technicality, but it's going to be very important that you learn to use the correct one at the correct time. It says here, so if the measure of AB is equal to the measure of CD, remember we said if no line is on top, then that means the measure of or the length of. So we're talking about the actual length or number value associated with A from A to B. Then we know that if those measures or lengths are equal, then we know the actual line segments AB, I'm going to put the line on top, would be congruent to line segment CD. And if line segment AB is congruent to line segment CD, I therefore know from that that the measure of AB is equal to the measure of CD. Okay, so again, if we're talking about that number value, we use our equal sign with no line on top. If we're talking about the actual line segments themselves and just kind of saying this one is the same as this one, then we would have the line on top with the congruent symbol. The way we show congruence in a picture is we'll put little markings to show that they're congruent, like 1 dash would mean those two are congruent, or I might say 2 dash to show that those are congruent. Okay, now let's look at example 7. We are almost done here. So on example 7, it says, are AC and BD congruent to each other? So I want to know, is this length the same as this length? So if we go back to what we talked about at the beginning, quick, easy way to do this might be to count the spaces, but you have to be really careful with that. You have to make sure you know what each space represents. So, look and see what you think. What is the length of AC? If I go to count that, this is 2, this represents 2, this space represents 2, so I've got 2 plus 2 is 4, plus this one is just halfway in between at 3, so that's just representing 1 space, so I technically have a length of 5 there. If I go from B to D, I've got, sorry about that, I'm looking, I stopped too soon on the AC here. So if I go, I've got 2 plus 2 plus 2 plus just the 1 right here. So that's giving me a length of 7. And if I go from B to D, I've got 2, 2, 2 plus 1 more is 7. So since they have the same length, I would say that yes, they are congruent to each other. Okay, now a new term is a midpoint, and a midpoint is a point that divides a segment into 2 congruent segments. Okay, so midpoint does mean right in the middle. We said a minute ago, between does not mean right in the middle. It just means somewhere in between. Midpoint means right smack dab in the middle. So a segment bisector is another term, and it is a point, line, ray, or other segment that intersects a segment at its midpoint. So in this particular case, if I look at this picture, I can see that line J or point B is bisecting segment AC, meaning it's cutting it in half. And the way I know that it's the midpoint or the segment bisector and cutting it in half is I see these congruent marks here. So I know that B is right in the middle. So a few things I could say about this that you might just want to add in your notes is that point B is the midpoint of AC. Okay, so that's a true thing I could say about this picture just by the markings on the picture. Another thing I could say is that I could say line J is a segment bisector of line segment AC. That's another true thing I can say about that information. Okay, on example 8, our last little bit here, what I would recommend is read that question, see if you can draw a picture that fits that information, label your picture, and then try to set up a true equation based on your picture. And then I want you to come back on and check yours with mine. So go ahead and do that, please. Okay, so hopefully you set up your true equation. Hopefully you drew your picture, you labeled your picture, and you wrote your expressions on your picture. And then set up your true equation. And you can see here my equation is 6x minus 7 equals 5x plus 1. And I want you to see if you wrote the same thing. Sometimes people get a little confused with this one because it's not exactly like the other ones that we've done. They're thinking there's not enough information. I have to go something plus something equals the whole big thing. But in this case, that is not needed because they gave us this one little word here called midpoint that gave us more information. So I know that Q is the midpoint of PR, meaning it's right in the middle. So you can see that's why I made these congruent marks on the picture. And so if I see those congruent marks, then I know, oh yeah, it's equal on both sides. So I can set those two expressions equal to each other. Okay, now I want you to pause the video again, and I want you to go and solve for X, plug back in for PQ, QR, and PR to get those answers, since that's what they're asking for. And then I want you to see if you can find a quick way to check to see if your answers are correct. Okay, so go ahead and check yours with mine. Once I solved for X, I got 8. Once I plugged back in for PQ, you can see I got 41. For QR, I got 41. And then they also asked me to find PR, which is 82. And then, as a quick check, I just was making sure that 41 plus 41 is equal to 82. I labeled on the picture. Sometimes it's helpful to see that. If you want to write it out as the quick check, you can. But just to take the time to make sure that checks out. All right, just let me know if you have any questions on this, and I'll help you get it figured out.